Hello everyone. IEEE Power and Energy Society Young Professional present webinar on energy system modeling using HOMER software. Our presenter is Mr. Desire Musa. He is a multi-talent professional with experts in sustainable energy engineering. He is a researcher, renewable energy specialist, and writer. Currently, he is pursuing Master of Science and Sustainable Energy program, which is offered by Malawi University of Business and Applied Science. He also a member of IEEE Power and Energy Society, IEEE Young Professional, and IEEE Smart Village. He is also a chapter representative at IEEE Power and Energy Young Professional Region 8, Africa, Europe, and Middle East. He is a chair and co-founder of IEEE Smart Village Malawi University of Business and Applied Science Students Branch 2023. So we are welcome him for his to present a skills improvement program for engineers, and his online training is about energy system modeling using HOMER software. Welcome, dear Musa. You can now start, please.
Thank you, sir. Okay, let me start. All right, so we focus much on energy system modeling using HOMER software. To be specific, we use HOMER Pro. So by the end of this presentation, participants should be able to model energy systems using HOMER software and also optimize sustainable energy systems to meet stakeholders' requirements while minimizing costs and the environmental impacts. So first of all, we will focus much on modeling part and also introduce HOMER. And finally, we will do a tutorial whereby we will demonstrate how we can design as well as simulate and optimize energy systems using HOMER Pro. Yeah, so energy systems modeling, in the past, we used to do it manually, but nowadays, due to advancement in technology, we are able to do energy modeling using software that are available. So there are a number of modeling softwares that are used in energy sector. We have HOMER, we have PES, and MATLAB and the other modeling software that you can see on the screen. And majority of these softwares, they are specific to type of energy system that we want to design. For example, PES is mainly used for solar. And we have less soft, which is the force much on wind. But for HOMER, it is a modeling software which targets on multiple energy systems. That's why today we will focus much on this software. Yeah, so why do we need to use energy modeling software? We need to use this software because it helps us to maximize performance of energy systems by fostering design of choices in terms of life cycle cost by using energy modeling software. And also selection of energy systems based on user needs, as well as the locations, the other parameters such as solar orientation, flow durations, curve if you are dealing with hydro, and other climatic factors. And also, we need to know this software because it allows us to modify various energy systems based on their complexity. For example, energy modeling software it plays a key role in modifying energy systems design that is already there. And also, it allows us to evaluate impacts of energy systems on the environment, such as carbon dioxide emissions. Yeah, so generally, just as I've already explained on that, when you are talking about energy modeling, we can model solar systems, we can model wind powered systems, we can model any type of energy system that we want. but there are specific software that are dealing with those systems. But when you are dealing with the HOMER, we are allowed or we are able to do this, to do modeling or simulation using a single platform. So first of all, we need site assessment. So site assessment, it involves collecting data on energy demand, and also you need to collect data on required components and also price of material that you want to use in your energy project. And also there is also a need for data on energy sources. For example, if we are dealing with the solar, we need to know the solar radiation of that particular area, as well as wind speed if you are dealing with wind, fuel price if you are using conventional power systems such as diesel power systems, as well as flow duration curve if you will consider hydropower. So after you have the data, you can upload it in your modeling software and run the simulation. And once you run the simulation, you have several scenarios, and that will lead you to identify optimal energy systems. Yeah, so now let's go into HOMER, overview of HOMER. So HOMER is an acronym for hybrid optimization of multiple energy sources. So yeah, so HOMER, it allows you to model multiple energy sources. So it is a software used for modeling, analyzing, optimizing, and also you can do sensitive analysis. Yeah, so energy in energy sector, HOMER software is programmed to simulate and optimize energy system performance by allowing the user to make component selections, energy system sizing, as well as economic analysis. Yeah, so you as a user, you need to understand that HOMER is not only meant for engineers. It can be used by researchers, consultants, and also professionals. So it can be either in academics or even in the industry sector, because it mainly focus on microgrids. So this is just an example of microgrid with multiple energy sources. We have household, and we have a household. It can be a community which is powered by several systems. So it can be solar, wind, generators, or even hydro. Yeah, so products of HOMER Energy, it includes HOMER Pro software, which we will focus much on today. And also there is HOMER Grid, and we have HOMER Front, and as well as we have online tools, which is what HOMER Quick Start. Okay, so let's look into the types of HOMER software that are available at the moment. We have HOMER Pro, which is focused much on standalone microgrids. Yes, and we have also another one which is HOMER Grid, and the main focus on distributed energy. And you have HOMER Front, which is focused much on utility scale hybrid systems. So for today, just as I already explained earlier on, that our emphasis is on HOMER Pro. So using HOMER Pro, you need to know the components that you want. For example, if you want to, if your project is to use solar or wind, you have to know the component, and also you need to know the cost as well as the resource. Because HOMER modeling, it does economic analysis as well as technical performance of the components. So you need to know this. Yeah. So when you will appreciate this once I open the HOMER software, whereby you can see where we can enter the components that we want, the cost, as well as the resource. Yeah. So how HOMER Pro works. So HOMER Pro simulates energy systems. There are three scenarios that happen. So we have simulations, optimization, sensitive analysis, and there's modules. So we look on we look each of these in the next slide. Yeah. So simulation. It is at its core, HOMER is simulation model. It will attempt to simulate a viable system for all possible combinations of the equipment that you wish to consider, depending on how you set your problem. HOMER may simulate hundreds or even thousands of systems. It also simulates the operations of hybrid microgrid, just like the one that I showed you earlier. So it does this for entire year even in it also consider our operation. Yeah. And it calculates energy balance for system or configuration, determining feasibility and estimating systems cost, including capital, replacement cost, maintenance cost, and if the fuel project is involving maybe a generator which is powered by fuel, you also include that and other parameters. Yeah, so HOMER examines all possible combinations of system type in a single run and then sort the system according to optimization variable of choice. So the optimization part, it only helps us to identify the least cost option, because the HOMER estimates several, even thousands possible solutions, but the optimization part, it helps us to identify the least cost option. So that it also helps us to know the life cycle cost of our system. So on sensitive analysis, this is where we have to ask ourselves questions that if maybe we are considering to use wind turbine at a specific wind speed. So what if the wind speed changes? That's why sensitive analysis comes in. Another example could be where maybe we are trying to integrate a conventional generator in our system, and we include the fuel price. So what if the fuel price changes? So the sensitive analysis, it helps us to consider those parameters that we cannot control. So on models, HOMER Pro can be customized with up to 9 individual modules to meet your specific model. So it can be biomass, hydro, combined heat, power, and other modules that you see on this slide. Yeah, so how to install HOMER Pro? HOMER Pro, you first of all, you need to visit the website, the HOMER Energy website, where you need to create an account. After creating an account, there is a free 21-day trial where you can download, and once you have installed, you can do the designing, and also for free for 21 days. But once the 21 days expires, you need to find the license to do that, to extend your operation. So first of all, you need to take advantage of free 21-day trial. Yeah, so you can download any version on HOMER. You can just type homerenergy.com, or you can just search on the internet HOMER. So you go to the website and check. Yeah, so once you install the HOMER, it will show you this interface. Yeah, so I'll just go through this quickly so that we can go to the HOMER software and demonstrate how we can model and design a real system. Yeah, so the interface for HOMER Pro, we have file, design section, have schematic section where you can see the technical diagram of your systems, and there is also required changes section where the suggestion pops up so that you can work on those, and there's also load section where you can add the load, and the component section, resource section, project, and also help. So I'll just go through this, then we'll proceed with the software itself, the tutorial. Okay. Yeah. So for the file section, file has home and the pages where home library, results, and design can be accessed. And there's design section. So for design section, you need to add the name of your project, the author. If you are the one who are designing the project, you need to include your name on the author. And there is a section where there is a description, and there is also a second discount and the inflation rate. So on discount and inflation rate, you put the rates that are within your area of your project. For example, in your country, you can know you can find out the discount rates and inflation rates, because this will help you to understand the net present value for your project throughout the life cycle. And also project location. So for project location, it helps you to understand the energy resource that is available in your area, because hydro power resource in Malawi might not be the same in Canada or in India. It might be different. So it differs based on location. So that's why we need to specify the location. Yeah, so one configuration component, this is done on schematic page you will see when we will be demonstrating on software. Yeah, so we have, you already know that we have two types of electricity. We have AC type, that's alternative current electricity, and the DC current electricity. So the HOMER software shows those. For example, solar generates DC, but if your load requires AC electricity, it means we need to convert that DC electricity to AC. Yeah, so HOMER will do that on its own. And there's the required changes section where you can see the suggestion pops up and work on that. Yeah. So we have load section where we upload we upload our load. However, HOMER Pro have generic load. Once we specify the location, it can synthesize the load of that particular area. However, it gives the generic load profile based on HOMER measures for that area. So it is advisable that if you are designing a project for a particular community, you need to first of all to collect data, a site energy assessment or energy demand assessment, so that will guide you on the exact load for particular community, or even if it is for the residents, it will give you that. So the load should be for the entire year. That's 8,760 hours. Yeah, so for components, we can add the component that we want. If you want to, or if our project is to do with solar, we add solar. If it is to do with the wind, we add the wind turbine. If it is to do with hydro, we add hydro turbine. For resource, each energy component has got its energy resource. For example, solar, it goes solar gas. We have wind power to the source wind, and the other parameters such as hydro. We will see this in our tutorial. For the project section, This does much on economics, context, emissions, optimizations, search space sensitivity, and other parameters that you can see. However, the main point that I would like to emphasize is that on economics, this is where you can change the currency, because HOMER by default it works with United States dollar. So by default, the currency is in US dollar. But maybe if you want to use the currency in your country, then you can go you can change the currency by going on the project and economics. Then you change the currency based on the country that you are based in. For help, this section whereby maybe you need some help, maybe in terms of your modeling. Maybe you want to understand details about HOMER, you can go to the help section. So HOMER Pro, it has the exact section. So HOMER software optimizes the lowest possible net present cost of energy system based on generation capacity and economics. So it works around the capacity of the system as well as the economics. So it makes the decision based on the generation capacity and the economics. So it gives the suggestion whether the system meet the demand, and if the system is infeasible, the HOMER highlights the reasons why that system is infeasible. For example, for some scenario one, this is system it was infeasible. The HOMER Pro it displays it's again that the system is infeasible due to maybe insufficient or insufficient generation capacity or something like that. Yeah. So we have this scenario and another scenario. Yeah. So let's go to HOMER Pro software. We can just go through this in the next 15 to 20 minutes, whereby we need to design a hybrid microgrid, which consists of the following technologies. So solar, wind turbine, biomass, that's biogas generator, battery storage, as well as conventional generator, to be specific, diesel generator. And we use the electric load, which we have for particular community, and also biomass data to be used for generating biogas, which can be used to power a biogas generator. And the location, we use the Blantyre, Malawi, and the cost of gathering and transporting biomass for this tutorial we consider to be $15 per ton, and the nominal discount rate you just consider to be 5.16%, and inflation rate 2%. So let me open the software. Yeah, so this is how HOMER Pro interface looks. First of all, we need to specify the name of the project. So I'll just specify it be hybrid microgrid project. Author, I'll just put my name. C Mussa. For the description, you can just paste the tutorial that we had. So it's design a hybrid microgrid, which consists of the following technologies: solar PV, wind turbine, biomass. Okay, to make this clear, let me so we have solar, wind turbine, biomass, that's biogas generator, battery storage, conventional or diesel generator. So when I was presenting using the PowerPoint, I said that we need to specify the location of the project. So this is where you need to specify. For example, if our project in Toronto, Canada, if you search here, you see it moves here. Something if our project is in Panama, search here, that's the area. So in a project, let's say Mumbai, India. Yes, HOMER will select that area, and everything that we'll be doing, it will be the resource, the solar radiance, the wind, it will be of that particular area. But since the project that this tutorial, we said that our project should be focusing on Blantyre, Malawi. So let me put Blantyre. So if I check the location, it moves here. So I can zoom in. It be, this is the state. Can zoom it to region. Okay. So I can switch region or city. So that's it. So, yeah, so I can put it on city, or let me just put it on region. Yeah. So this is it. Blantyre. This is where our project is. Based on this tutorial. So now, once we are done, we need to go to discount rate. This is whereby this is where we will be able to understand the HOMER will be able to generate the net present value for our project based on the discount rate. So according to our question, when I do the tutorial, it's the discount rate. We said it's 5.16. Inflation rate 2%. We just leave it as it is. Annual capacity storage shortage. We just assume that our system will not have any shortage, so we put it 0. The project life cycle, since we are doing solar and other systems, we just put it to 25 years. Yeah. So once we are done, we need to add the load. So to add the load, we go here. So we can add, there's the load 1, 2, then we have deferred load. But for this tutorial, we just focus on this. So as I was explaining earlier on, I said HOMER has got capacity to synthesize a load based on the sets we have selected. However, it is advisable to know the energy demand. For example, if it is for the community, you have to know that, so that your system should be realistic. So in this case, I will upload the load profile. I'll upload the electrical data that will help us to generate the load profile for the system. So let me import so go to here. Yeah, it's electrical load data. So I click here, open. So here it will show that we need to specify when the load demand assessment was done. So in this case, let's suggest that we did it in 2022. Yeah, so click OK, then we import. So once we import, you can see we have daily profile, we have a seasonal load profile that is generated based on the electric load that we have uploaded. So this is our load for whole day. So it is up to, you can see 0 hour up to 23 hours here. Yeah. So this is for January, but you can also see other load for the entire year. So January, February, March, up to December here. Yeah. So once we are done, we have added our load. Now we need to start adding the. Let's go to home. So whatever we'll be doing, it will be appearing on schematic section here. So we have added the load. Now we need to add solar PV. So we go to component, select PV. Yeah, so there's generic. We have generic flat plate, concentrating PV, and other generic PV that we have here. Yes. So it's better to go for catalog because catalog it has several brands that are available on the market. Yeah. So let's go to catalog. We click complete. Then we can select any brand that we want. Okay. So before we select our brand, we need to know our load. So the load has got 161.79 kilowatt peak. So our PV will be based on this. Our system should be able to should be able to sustain this. And so let's go to catalog, and you can choose any of these. But for this tutorial, let's go to. Okay, let's select GECO. Yeah, GECO Eagle panel, which is rated at 300 watts per panel. So let's select this. So you can see it has been added here. Now we need to put the price. So let's assume these are not the realistic prices. We just use them for this tutorial. So let's assume that the initial capital for the solar PV panels is 1,200, and the replacement cost is, let's assume it's also $1,200. And since solar panels, they are not movable, they don't have movable parts. So the maintenance that we will be doing, it will be much on, it will be forced much on cleaning the panel, such as removing the dust on the panel. So let's just put it $12 per year. hours per year. Okay. Now here, sec space, we have to make sure that our system is able to sustain our load, which is 161.79 watt peak. So let's just assume it's that our solar PV should be able to generate this. We should be able to generate to 200 watt. So as soon as I've done this, it will be added here. So let me go back to home. Now wind turbine. So for wind turbine, we go to components, then we select wind turbine. So we go to catalog. Before we select the system, we have to consider that this solar PV that we have designed to be able to sustain this load. However, since during night we will not have sunlight that will enable the solar technology to generate the power. So we have to integrate other systems that will supplement the system during during night, for example. Yeah. So let's check on the load to see at night. So at night the load is almost it's almost 60 kilowatt. Yeah. So when we are selecting solar, when we are selecting other components, we have to base our argument on that. So let's select wind turbine. Go to catalog. Let's select go or eco wind turbine. So let's yeah, let's select the wind turbine, which has a capacity of 30 kilowatt. So let's select this. So it will show you this, it will display this picture. Now, this platform, you need to add the capital for your wind turbine. So in this case, let's just assume that our capital for this is 3,130. And for the replacement cost, let's assume to be 200, because wind turbine, we're gonna maybe we can only replace the turbine, but the pole will be maybe intact. So let's just put to 2,000. And since it involves moving parts, we should expect more maintenance. So let's assume that $70 for maintenance. Now, here, you can see it says power curve provided from a manufacturer and assumes wind speed at hub height, so applicable to both versions. So they say a hub height of 16.8 meters or 23.8 meters for hydraulic tower. Okay, so the hub height for this is 23.8 meters based on the area that we have selected. Now the question is, what if the wind speed changes? That's when we need to do sensitivity analysis. So we go to advanced. So or you can also change here. There's where there's hub height. So you click here. So say hub height is 23 meters. So we say, what if it is 24.8? Yeah. Now we need to add another component. Let's go to home. On our description, project description, we need to add the biogas. We need to add biogas generator. So to add the biogas generator, we need to go to component, then we select generator. So we have to go to complete catalog and select the generator that we want, but it should be powered by biogas. So for this tutorial, let's select generic biogas genset, which we can size by our own. So let's go to So let's go to generic biogas genset, size your one, this one. So once we select that, HOMER will display where we need to add the capital cost, replacement cost. So since our system, we need to, we already have solar, which is able to sustain this, but maybe during the day there are some fluctuations, and also maybe we already know that during the night there's no generation of power. So we can just assume that our debugger generator should generate 100 kilowatt. And since we have reduced the cost, let's assume the capital cost for the generator is 4,000. The replacement cost, it's 3,500. And let's assume our operations and maintenance cost per operation hour. Let's assume it's 50 plus. Now you can see it has been added here. Let's go back to home. Now let's look at battery storage. So battery storage, you go to components, battery storage. So we can select any type of the battery that we want based on our energy demand. So let's assume that our battery should be able to, since it's a microgrid with multiple power sources, let's assume that our battery should be able to provide power for a day. So let's select components. Let's select on components. Select complete catalog for the battery. So we have different brands here. Yeah, so we can select any. So for this, let's select the generic ion battery. So let's go to okay. Let's select the generic ion battery. This one, okay, its capacity is 1,000 kilowatt hour. So if you go back to the load here, the electric load, so this can be the load for the community. It's 948.77 kilowatt hour per day. So we assume that our battery should be able to meet this, but should be sized according to energy demand. We should be able to meet this for at least a day. So if we select the lithium-ion battery of 1,000 kilowatt hour, it will be able to sustain that. So let's add it. Yeah. So we have capital cost, investment cost. So we can change based on the prices that are available on the market. So for this, let's assume that the capital cost is 570. That's 5,700. 570,000. Yeah, 570,000. And the replacement cost should be 570,000 as well. Okay, it's operations and maintenance cost. Let's assume it's 100. So on search, that's string one string. Okay, so we do HOMER optimize. Okay, now we can see the battery has been added here. Let's go back to the home. So we need to add conventional for diesel generator. So what we need to do, we go to components, select, we select generator, then go to catalog. So let's assume that our generator should be Sun system. So Sun, the brand. Yeah, so on generator, we need to select the diesel generator. So let's use the generator with the 10 kilowatt. Yeah, this one. So we add, it will show this. So we have initial capital, displacement capital, we have operations we have operation and maintenance cost per operation per hour. So that's it. We can just leave it like this. For the fuel price, so for the fuel price, we can do sensitive analysis now on this. Okay, since fuel changes, so we are dealing with diesel. So diesel changes with time and based on the demand and supply. So according to Maritime Energy Regulatory Authority, at the moment, the prices for diesel per liter, it's 1,920 Marikwacha, which is equivalent to 1.17. So we can say, what if the fuel prices changes? So we go to advanced here. You can see if we have already selected the type of fuel, diesel. The price is 1.17 dollars. So we can, let's assume that what if diesel fuel changes, the prices changes to $1.5, or maybe it changes to $2. So HOMER will consider all these options when designing the system. Now let's go back to so we have added solar PV, we have wind, we have added the biomass generator, we have added battery storage, we have converted the conventional generator. But if you can look on the schematic diagram here, the load is only connected on AC bus here, AC bus bar here. So we need to add the converter or inverter, which will convert the DC electricity generated from battery and the solar, so that it can be converted and into usable AC power. So for that, let's go to components. Then we go to converter. So this is just the generic value. We can use the catalog to select the exact brand that we want. So I will use the catalog. So catalog, let's select Sun. Let's select Sun Epix 200K, so that it should be able to generate, should be able to convert enough power which can sustain the load. So let's say Sun which has 200 kVA. Okay, so add. So we say replace component. Component will be replaced by the one from the list library. Yeah, so we have to select OK. Yes. Now, let's assume that our capital for the converter, the capital for inverter, it's 31,200, and the replacement cost is 9,000. Operation costs, let's assume it's 1,340. Now, there is lead here. Okay. If you put your case there, it says the rectifier efficiency must be greater than 0 and less than 101. So in this case, let's assume that our converter, it has 98% efficiency. So the moment I put in there, you see that it has disappeared now. Now let's go back to home. We have added solar PV, we have added wind turbine, we have added biomass, we have added the battery and generator as well. Now what we need to do, we need to go to the required cases. We have added resources. So for added energy resource, based on the component that we have selected, we need to go to resources here. So since we have solar, we need to put, you can select NASA or National Renewable Energy Laboratory data. But for this, let's just take for NASA. Then we can select for windy and also temperature. And once we have done that, we need to download the, so you can say, it says resource were downloaded successfully. You see the section will disappear. Now we have only one resource which we need to add. So that's for biomass, the generator that is using biogas. So it uses biomass to generate that biomass is used to generate biogas, and that biogas it's used as a fuel for biogas generator. So you can click here to add the biomass data, or you can go to resource and select biomass here. So you can do it based on the requirement per day or each month. So we use the data that is already available. So let me just show available biomass data per day throughout the 12 months. So let's this. Okay, let me go back again. Biomass. Okay. I select paste. So I've pasted the biomass data. Now, if I go back to the home section, it says the tutorial says that $15 per ton. That's this amount is required for gathering and transporting biomass. So $15. So let me go back to biomass resource. Then we put average price per ton. That's we said it's 15. So let me go back to home. So now it's like we have done everything. We have added the component that we need, the cost, and everything. So now we need to learn the HOMER model. So once we run the HOMER model, it tries to optimize the lowest possible net present cost for systems. So it will simulate several thousands. Sometimes you can be hundreds, sometimes thousands systems, but thousands systems that can be considered. But HOMER, once it does the optimization, it helps us to identify the least cost system that is viable, both economically as well as technically. So as I have already explained earlier on, that HOMER, it does technical performance of the system that we have designed, and it also works on analyzing the economics, such as the payback, the return on investment. So that is based on the discounts that we have tabulated earlier on. So sometimes it takes time to optimize based on the design, but now we will. But now, since this has got small data, so we have to. It doesn't take any time. It doesn't take a long time. So you can see here we have winning system. We have base system. So we can go to the table where we can see the least cost systems. So we have sensitive cases, optimized that case. So we can just the first one here. It's the one with the lowest possible net present cost. So we should select that one. Yeah. So once we do that, we need to go to cash flow. Cash flow. This is how our system cash flow will be for 25 years. Compare the economics. So the economics, you can see the present with the return on investment, the internal return, the simple payback. Same thing on electrical. We can see even excess electricity. So it means we have only 1.2% excess power. Yeah. So once we have done that, this we can also look at the performance of the systems we have designed. Then after that, we need to create the proposal. So HOMER will generate the proposal based on the information that you have tabulated in the during modeling. So let's take the name of the client. Let's take IEEE IEEE it's IP. Position, okay, we can just say utility. Address, we can just leave the address. It's fine. Then the thing that I've already troubled the area on to display here. So let's go to next. So here it will show you areas that you should consider in your proposal. Positive generate the proposal automatically. So you click next. So you choose whether your proposal you want it to be in later or recursion. So we just put it later. Then we open report. So sometimes it takes several minutes, but since we have used the few data, that's why it has popped up area. So this is the proposal that has been generated based on the parameters that we have included. So we have it will show you area. You can even edit it and add information that you want. So here is project summary, add your company name. So it has already tabulated this, but you can still edit. Yeah. So the current systems, proposed system, like simple way back, return on investment. Yes, you can add the name of your company. Yeah. So it shows the performance of your systems as well.
Yes, yeah. We have
Yeah,
some questions.
can you display the PowerPoint?
Yeah, PowerPoint.
Yeah.
For of that, you
So
can answer these questions.
yeah, we can just we can suppose we are almost done. I'm ending with one side. We can just go to then we can go to the question. So
Okay.
as I was explaining, this is the tutorial that we had. You can do it at your own. You play around with the homework, but that's how it works. Yeah. So this is the hybrid microgrid that we have designed. So we consider this to be households. It can be a community. So it is powered with the biogas generator, diesel generator that we have done. We have a converter here, solar, PV technology, we have wind and battery. Yeah. So these are the references. Saf has already introduced me. Yeah. So for inquiries, you can reach out to IEEE Power and Energy Society Young Professionals, Industry Outreach, and the Entrepreneurship Subcommittee on this this email. Yeah. So if there are some questions, the floor is open.
Thank you very much, dear Zach. Yes, someone is asked about is this software is available in a free version or another type
Okay.
of version, trial or
Okay.
something like that.
Okay.
Academy.
All right, thank you. The software is very. Let me go back to this slide. The software is available on HOMER energy website. So you can just say HOMER software. So HOMER, it has three softwares that are used in the energy sector. And the first one is the HOMER Pro, which we were doing. And we have another on the grid, the HOMER grid and the HOMER Pro, the HOMER front. So for any type of this, you can access the software on HOMER page. There's free version, but it's only for demo. It only runs for 21 days. So once the 21 days expires, you need to find you need to purchase the license for that HOMER so that you can continue using it. But if you are, but you are at the moment, you can enjoy the free trial, free 21 day trial. You can do any system, you can design any system, but after 21 days, the trial expires, so you need to renew it by finding license. So you do it you do that by purchasing through HOMER. You can do that on HOMER website since you already have an account. Yeah, I hope I've answered the question.
Another question from Jacob. He asked, which one is the best among these three software?
All these software, they are best, but now it depends on the type of project that we want to do. For example, in this scenario, if you're following me properly, I said that HOMER Pro, you can design the you can design it focus on microgrids. So microgrids, they can be standalone, or you can connect it to the national grid as well. But mostly it is done on micro. So if your project is on microgrid, then the best software to do that it's for HOMER Pro. But if you are dealing with the distributed energy systems, you can go for HOMER grid. And also for the HOMER Pro front is for utility. So all these softwares, they are the best softwares. They do extraordinary work. But now it depends on the nature and type of the project. So for this webinar, we first much on the microgrid, whereby a microgrid we can power a community. We can have a commercial, whereby you generate your power, you sell it to the community as well. As well as you can also do it, maybe I have maybe a factory, so I want to use multiple energy sources, whether generators or wind turbines, solar. So HOMER will also be the good option for that.
Okay. Another question is from Luis. How can you get the exact number of batteries and solar models from the simulations?
Once you run the simulations, there is a section whereby you can. There's the HOMER optimizer. If you do that, it will run the estimation and identify the even number of the battery to be in the strings. So once you run the estimation, it will tell you. And sometimes, as I was explaining earlier on, that when you are dealing with energy modeling, there are softwares specifically for solar. There's software specifically for wind, but for HOMER, what it does, it's to look at technical technical performance of the system as well as the economic point of view as well as the design. So you can do that by running the HOMER optimizer, and also you can also use the other available softwares on so to also to size the battery. Yeah, but for the for HOMER, you can just use the HOMER optimizer to do that.
Okay, another question is about what causes the capacity not meeting the demand after the simulation.
Okay, what causes the capacity not to meet the demand after the simulation? There are several factors. If you are following me properly, when I was going through HOMER software, there was a section whereby we were selecting the component based on the load. So we have the load. We had peak load. We had the so if your components are not meeting the load demand, that's when the HOMER will tell you after you run the simulation. The HOMER will tell you that your system is not meeting the energy need. So what you need to do, you need to go back. That's why in HOMER you can design the system. So you design it, you go back to the system, you add the capacity to meet the demand. And this also happens on economic point of view. Just as I have already explained earlier on that HOMER also look at life cycle cost, or we can say net present value for the entire system, for the entire lifespan of the system. So it can be for the entire 25 years. So if your if your estimation show that you are making losses, no, if your projects for the commercial purposes, so it shows that you are making no returns on that, you can go back and look at the prices, because if the prices for the components are higher, despite that the system will be meeting the demand, but now there'll be no return on the investment. So you work also on around that. So for the capacity, you change the capacity of the load by either adding or increasing. You add if the capacity is lower. You decrease the capacity if the capacity is high. For example, if there is too much excess power. Just to give an example, you can design your system which is meeting the load demand, but if you check, you find out that you are only using 20%, which means 80% is excess. So you go back and redesign on that capacity. So it's, you decrease the capacity. If it's another way around, you add. Yeah.
Okay, last question is asking about can we secure and install the three types of software really online?
No, you can only you can only score one type. For this one, okay, let me just go. Okay. Yeah, you can only secure one type of HOMER. So if you choose the HOMER Pro, you create an account by using your email, then password. After that, you can download the software. You can use it for 21 days. After that, after 21 days has run out, you have to purchase it. Yeah. So you cannot use all of them at one. You need to choose one.
This question is kindly confirm if the load input is in kilowatt hour or kilowatt.
Okay. load input, okay, for kilowatt hour, kilowatt hour, that's when we are dealing with the battery. So battery rating, the battery rating, it's power per unit at time. So it can be kilowatt hour. But on the other hand, the peak load can be uh, kilowatt. That's why that's why when we are that's how when we are modeling using HOMER, the on load this the on load, it will show you both what peak, it will be kilowatt peak, yeah, kilowatt peak, and also kilowatt hour per day. So that will tell that will guide you when you are sizing the battery, as well as when you are selecting the component.
Okay, this question, I think this is the last one. Can QGIS perform energy simulation?
QGIS, of course, I have not yet worked with this. Don't find out, but for the simulation, it's not only HOMER that does simulations. There are a number of softwares that I've already shown you earlier on. So it depends with the project that we are doing. If it is only solar, we are good to go with the solar P50 and other software. So all modeling software, they do simulation, optimization. Yeah.
Okay, we now reach the end of this webinar. Thank you very much, dear Desire, for this wonderful lecture and informative. Peace for all. We have another webinar on the Thursday this week. Thank you all, and goodbye.